this morning's lesson, we're going to identify the various components and various types of graphs, as you can see from our learning intention up there. You already know what edges and vertices are, and so on that diagram there, how many edges are there? Just count for yourselves. How many edges? Edge is the line joining two vertices. 1, 2, 3, 4, 5, 6, 7, 8. Agreed? 8 edges. And how many vertices? 6. A, B, C, D, E, F. This is again looking far forward into the unit, but there's also something called faces. If we draw a box around the outside of the whole thing to determine the area that we're looking at, we also count faces. 1, 2, 3, and 1 around everything else. There's 4 faces. Now, you don't need that just yet, but you will need it later on. And one of Euler's contributions to maths is a formula that relates edges, vertices, and faces of a network. There's a formula that connects them. It always adds up to the same quantity. Anyway, so that's just a bit of supplementary information there. All right, 4 faces as well as the other things. 1, 2, 3, and 4. There's always one inside the box, but outside all the network. Next thing, the degree of a vertex. You've already met this. So if Anna is vertex A, what's the degree of vertex A? Remember? 3, yep. 1, 2, 3 lines coming off it. Francis? 3. Brett? Paula, 3. Can you remember from 2 days ago, is this network traceable? What was the rule we could just...
We had to start at an uneven number.
You have to start at an odd number, but also the requirement was 2 odd nodes only. How many odds are there? There's 4 odds. It's not traceable. You can try it later, but I don't think you'll find it's traceable. If there are 2 odd nodes or no odd nodes at all, it is traceable. And remember, if it's, you've got to start at one of the odds and finish at the, and you'll finish at the other odd, if it's traceable. But that, again, that's not in this unit. That was in yesterday's unit. Some of the stuff I'm giving you is coming up next week. Some of the stuff I'm giving you, you've done already. But that's to remember, the degree of a vertex. Traceability will come up later in 6D or 6E. If I try tracing this one, up there, starting at an odd one, go down to there. I can go down there, or I can't go up there, so it's not traceable. Introducing something new now. This is a loop down here. Ethan's got a loop on there now. A loop is merely where a vertex, an edge goes from a vertex and back to the same vertex. So we're identifying loops now on this slide. So as I said, we're doing all the features of different kinds of graphs. So that's a loop. And what's the degree of Ethan now? It is 4. You count that as 4. So that's only one edge, but it is added 2 to the degree. Otherwise, no change. There's still 3 odds, so we still can't do it. This is the definition of a simple graph. So I'm going to give you a definition of a simple graph. No loops, and also no multiple edges, which I haven't actually mentioned multiple edges, so I'll mention it now. A multiple edge is where you've got 2 or more ways of connecting 2 vertices. That's called multiple edges. There's 2 ways of getting from A to C, if this was a road map. 2 roads going from A to C, C to A. Which that one should now, how many odds now? 1, 2, what? E out there is an odd, because it's only 1, so there's still too many odds, aren't there? Yeah, too many odds, so it's not traceable either. So make a note of what a multiple edge is, but a simple graph is one which does not have any multiple edges and no loops. Here's another component we haven't looked at before. It's called an isolated vertex, which you can have on a network, but it's just that there's no connections to E, like a town where you can't drive in, you only fly in or whatever. It'll be a different network. Or there may be roads, but no flights. So just the terminology, isolated vertex. If you hear about an isolated vertex in a test question, E is an isolated vertex. I think this is the last one. This is what a complete graph looks like if you hear about a complete graph. I haven't said what it is. Can you sort of guess what a complete graph might consist of by looking at that diagram? What's new? What's different about this one from all the other ones we've looked at so far? There is a crossover, but that's not what makes it complete. It's correct. You normally wouldn't. Yeah, that's good. You got it again. A is connected to B, C, and D. B is connected to A, C, and D, and so on. They're all connected to each other. That is a complete graph. Normally, you would try and draw it without any crossovers. So if we did that, you'd have to do something like that to make it without. So that's also a complete graph, because everything is connected to everything else. You can see that it's the same thing, can't you? A, B, C, D. That's also a complete graph. So it doesn't have to have crossovers. Shouldn't have crossovers, really. Now, you may have missed... Oh, no, sorry, there is one more. I'll come back. If you haven't finished your notes, I'll come back. I just want to get through everything first of all. One more, subgraph. On top is A, B, C, D, E, F. There's 3 possible subgraphs down the bottom, but only 2 of them are actually subgraphs. Which one isn't? The third one? Yeah. That is on there. A, B, F is on there. That is on there. But that is not there, because it's got this extra multiple graph connecting A and B. So what I'll do next is I'll go back to the first note, and you can just make sure you've got the notes that you want. And then I'll go on to the next page after this, which I think has the game on it. Okay, so I'll go back, and if you missed anything, there's your chance now. Edges, vertices, and faces. All right, I've done that before. Can I move on? Just say no if you don't want me to move on. Degree of a vertex, just count up the connections. Move on. Loops. A loop adds an extra edge, and adds 2 extra to the degree. Simple graph, no loops or multiple edges. Isolated vertex. Complete. Everything connected to everything else. Subgraph. A component without all the features. But it can't be anything different. Now, if you feel so inclined, you can now play this little game. It's when you've got a long lesson now, so you've got plenty of time. Game of Sprouts. You've got two players, I guess. 2 or more points drawn on a piece of paper, which will be the vertices of a graph. So just draw any 2 points, then players take it in turns, presumably take it in turns to start, adding edges according to the following rules. Each edge must join 2 vertices, or to itself, in other words, a loop. Each time a new edge is drawn, a new vertex must be added on the edge. Edges cannot cross nor pass through a vertex, whatever that means. No vertex must have a degree greater than 3. Last player to add a new edge wins. Up to you. You can sit there and play Sprouts. There's an example in the textbook of what you can do and what you can't do. Otherwise, the whole of the exercise by the end of the lesson, please, which is on pages 207 to 9.